Hi, my name is Julie Kallini, and I'm a computer science PhD student at Stanford University. I'm excited to be talking about our paper, False Friends Are Not Foes, Investigating Vocabulary Overlap in Multilingual Language Models. I want to give a big thank you to my wonderful co-authors. Subword tokenizers trained on multilingual corpora naturally produce overlapping tokens across languages. Let's take English and Spanish as an example. Some of the shared tokens may correspond to strings that have the same meaning in both languages. For instance, the word actor is a cognate between English and Spanish, so it has the same form and meaning in both languages. Named entities like Batman always have the same form and meaning in any language. But some of these shared tokens have the same form with different meanings. The string PIE corresponds to a dessert in English, while it means foot in Spanish. These are known as false cognates or false friends. How do such overlapping tokens affect multilingual language models? More specifically, does token overlap facilitate cross-lingual transfer or instead introduce interference between languages? Prior work offers mixed evidence, partly due to varied setups and confounders. So we revisit the topic of vocabulary overlap in this paper. In particular, we distinguish different types of overlap based on semantic similarity of the tokens in the two languages, and test how this affects cross-lingual transfer. We trained 24 bilingual language models from scratch on 6 language pairs, each under 4 controlled vocabulary overlap settings. First, in the full overlap setting, the tokenizer's native subword overlap is shared. This represents an unaltered multilingual training setup. In the high similarity overlap setting, only tokens with the highest cross-lingual similarity are shared, and all other tokens get an instance in the first language and a separate instance in the second language. In the low similarity overlap setting, only the tokens with the lowest cross-lingual similarity are shared. And finally, in the no overlap setting, the two languages' vocabularies are completely disjoint and there are no shared tokens. We train on 6 various language pairs. English is included in every pair to reflect multilingual training scenarios that are realistic, where English is typically the dominant language in pre-training datasets. The second language is selected to cover various language families, scripts, and typological distances from English. We use the CC matrix corpus, a large collection of high-quality WebMine parallel texts, for bilingual model training. Our base tokenizer is the multilingual XLMR tokenizer. To partition the tokenizer's native overlap into high and low similarity subsets, we extract occurrences of the shared tokens from the CC matrix corpus and rank them by their semantic similarity between the two languages, using XLMR for cosine similarities. For each language pair and vocabulary overlap setting, we pre-train a separate model, resulting in 24 bilingual models in total. All models are autoregressive transformers equivalent in size to GPT-2 small. We first ask, do models learn similar representations for high similarity tokens and more distinct representations for low similarity tokens? For a given language pair, we take the 500 most and least similar overlapping tokens ranked by XLMR as described before, as well as 500 random pairs as a control. We then extract contextual embeddings for these tokens from a middle layer from each of our models and measure their similarity in the two languages. We find that any kind of overlap produces embedding spaces that capture cross-lingual semantic relationships, an effect that is much weaker in models with disjoint vocabularies. We found that this effect was fairly robust across language pairs. We further fine-tune and evaluate our models on 2 multilingual downstream tasks, namely natural language inference and question answering, in a standard zero-shot transfer setup. We find that models with overlap of any kind consistently outperform those with disjoint vocabularies, and transfer generally improves as overlap increases. Overall, our findings highlight the advantages of token overlap in multilingual language models, and show that substantial shared vocabulary remains a beneficial design choice for multilingual tokenizers. Thank you for listening.